So this question is from motion in a straight line. They have given you velocity time graph between 0 to 10 seconds. From 0 to 5 seconds, velocity increases linearly up to 12 meter per second, and then velocity decreases linearly to 0 for the next 5 seconds. You have to find distance from 2 seconds to 6 seconds. Now 2 seconds means somewhere here, 6 seconds means somewhere here. So from 2 seconds to 6 seconds, you have to find the distance curve. Now, first understand how the motion looks like. In this part, velocity is increasing, but it is positive, right? Positive, because this graph is in the first quadrant. So in the first quadrant, y coordinate and x coordinate is positive. So from 0 to 5 seconds, what happened? Velocity is increasing. That means the body is moving faster and faster. Right? After that, what is happening? Velocity is decreasing, but it is still positive. So velocity decreasing means what? It will move slower and slower. And then finally it will stop. But it is always going right side. It is never coming back. And if you don't come back, then you know distance and displacement will be same. So if you go in a straight line without coming back, then distance and displacement will be same. So though they have told find distance, we can find displacement, that will be same only, right? Now if they ask the displacement from VT graph, then we know that displacement is always found from VT graph as area under VT graph. But the problem is they are not asking distance from 0 to 10. If they ask distance from 0 to 10, we will calculate this area. It is very simple. Triangle's area is half into base into height. But they are asking you from 2 to 6. Now when time is 2 seconds, what is the velocity? We don't know. Let us call it v1. And when time is 6 seconds, what is the velocity? We don't know. Let us call it v2. So since they are asking only distance between 2 seconds to 6 seconds, we need to find this area. Only this area. So that area would be the displacement or distance from 2 seconds to 6. But this area cannot be found if you don't know this length, which is velocity, and this length here, which is velocity. This is velocity at 6 seconds, this is velocity at 2 seconds. So how to find this and this? For that, we will make use of geometry. So let us call this point as A, B, C, D, E, F, G. Now from this diagram you can see triangle ABG and triangle ACH. Both of them share the same angle, they are similar triangles. So since this angle is same, this is 90, this is 90, we can write tan theta for this angle. Tan theta we can write opposite by adjacent, also opposite by adjacent. Because both the triangles, big triangle and small triangle, both the triangle have this same angle. So if angle is same, tan theta will be same. If tan theta is same, opposite by adjacent will be same. So what is opposite of this big triangle? 12. By adjacent of this big triangle. Adjacent is 5. That should be equal to opposite of this small triangle. That is V1. V1 minus 0 is gap. And adjacent of this triangle will be 2 minus 0, which is 2. That means V1 is how much? 24 by 5. So we found V1. Similarly, let us try to find V2. V2 means this gap, right? Velocity at t equal to 6 seconds. To find this length, we can make use of this triangle and this big triangle. So again, triangles CHE is similar to triangle DFE. DFE. This is D. So here again both of them are sharing the same angle. Let us call this angle alpha or something. So tan alpha will be opposite of big triangle is 12. Adjacent of big triangle. This is 10, this is 5. So this gap will be how much? 5. Opposite of this small triangle is B2 minus 0. B2 minus 0, B2. And adjacent is 10 minus 6. What is 10 minus 6? 4. So what is B2? 48 by 5. Right? So once we found this B1 and B2, 24 by 5 and 48 by 5, we can now calculate the area under the VT graph from 2 seconds to 6 seconds. So this would be the area. Right? So let us divide this area into this rectangle. Let us call this area as A1, this rectangle. Then we can take this triangle. Let us call this A2. Then this triangle, let us call this A3. And then finally this rectangle, let us call this A4. So that would be the total area under this VT graph from 2 seconds to 6 seconds. So the displacement from 2 seconds to 6 seconds would be this rectangular area. This rectangular area, remember, plus this triangular area, plus this triangular area, plus this rectangular area. What is this rectangular area? Length. What is the length? 2 to 6. So what is this gap? 4 into this breadth. What is the breadth? 24 by 5 minus 0. 24 by 5. So length into breadth finished. Right? Area of this triangle. A2. Remember A2 in this triangle. So that triangle will be half into base. What is the base? Look carefully. Remember, we are talking about this triangle. This triangle. So base is 5 minus 2, 3. What is the height? Height is 12 minus 24 by 5. 12 minus 24 by 5. Plus this 18. This 18. This part. This is also triangle. So half into base. What is the base? Here 5, here 6. What is the gap? 1. What is the height? This height is 12 minus 48 by 5. 12 minus 48 by 5. Plus. Now we are left with this rectangle, right? This rectangle. Observe carefully. So length is how much here? 5 to 6. Gap is 1. So this length is 1. This breadth is 48 by 5 minus 24 by 5. 48 by 5 minus 24 by 5. So that would be the total area under the VT graph from 2 to 6. Now this calculation is like 4 into 24. 4 plus 60, 1, 3, 4 to 8, 9. 96 by 5 plus 3 by 2 into 5. LCM 5. 60 minus 24. 60 minus 24 will be how much? 36. Plus half into 5 LCM. 60 minus 48. 12. Plus 5 LCM. 48 minus 20. That will give you 96 by 5 plus 4 18 are 36, 3 8 are 24, 4, 2 carry, 3 1s are 3, plus 2 5, 54 by 5 plus 2 6 are 12, 6 by 5 plus 48 minus 24, 24 by 5. Here LCM will be 5, 96 plus 54. Here will be 96 plus 54 plus 6 plus 24. This if you add, you will get how much? 0, 150. 150, then this is 30. So 150 plus 30, 180 divided by 5. That will be 5 3s are 15, 3 carry 5 6 are 30. So answer is 36 meters, right?